Hi guys, this is my OXS setup in which you see the processor, the RP2040, which exhibits some outputs here on this row, and then on the output I connect the primary port from the receiver here, which is called in iBus servo. It is the S-bus output. And then I have connected two servos, one on this pin and the other one on this pin. Okay, the first servo will be acting as ailerons, and this one will be acting as elevator. At the other side, you see the GY86 sensor to perform some altimetrics measurement, plus also the gyro and accelerometer. So I will try to show you how to program this little thing in order to make it work as a gyro compensation device, the new features introduced in OXS. First of all, let's start with the transmitter. I'm working with an OpenTX, rather HTX Radiomaster TX16S, which is quite easy to program for this gyro system. I program a test plane like this. If we enter the menu of the test plane, going to the input, I will just show you a very simple plane where the aileron is in channel 1 with 100% stick aileron. Elevator is this one, throttle is that one, and the rudder is this one. Okay, just very simple at the input level. I have no fancy things, no expo, no nothing. It's very simple one to start with. I have added, forget this line, the test, what I call test, is something which is connected to the S2 potentiometer, but not used right now. What is important is this line. This line, I call it gyro programming channel, and the gyro programming channel is connected to the SC switch, this one, and it has three positions: off, in the middle, right, and hold. We will see how it works in the next explanations. If we go to the mixers are very easy. You see that I have prepared some mixings in order to make a mix between elevation and ailerons and elevation. Right now, forget the second line here, where you see the 0%. This means that there is no mixing which is active. The aileron is giving 100% on ailerons, and the elevation 100% on elevation. On the rudder, nothing. The rudder being here, nothing special. The channel 5, forget it. We can even cancel it. It's not used. And what is important is this one. This is my test. Channel 13 outputs 100% of the switch gyro programming channel. This is what is needed right now. Then you can see that we have added some more channels here: channel 10, channel 11, channel 12. Those channels are mandatory if you want to use the gyro function of OXS. You need to provide to the S-bus signal 3 channels, which are the direct copy of the sticks, aileron, elevation, rudder. This is mandatory for OXS to work. Not to forget a very important point: those channel 10, 11, and 12, which are the copy of the sticks, shall not be trimmed. So to avoid trimming, just press on this line, edit, and you will see those parameters here, you click here, and you see the trim. Nominally, the trim is active like that, but you have to cancel it. Okay, and you have to do it for all the three: aileron, elevator, edit. Click here, it shall be untrimmed like that, and same for the rudder, that shall be not trimmed. Okay, that's very important. So it is not the same as this one. You see that those ones, the beginning one here, are mixed channel from the TX. If I put here, for instance, 50% of elevation, 50% of aileron, 50 here and minus 15, we will get a mix for a delta plane, for instance. So those channels, channel 1, channel 2, are the channels which are nominally connected to the output servo, to the servos from the receiver. It should be connected here on channel 1, 2, and 4. 1 for aileron, 2 for the elevation, and 4 for the rudder. If we get some mixings, obviously the channel which is channel 1 will be a mix of aileron plus elevation. The channel 2 will be a mix of elevation and aileron. It is not at all the same as those one. Those one, channel 10, 11, and 12, are direct copy of the sticks. I just output on channel 10 100% of aileron, means this the sticks, the right stick here. I will unzoom a little bit. The right stick here is directly outputted on channel 10. This elevation sticks is the channel 11, and then the channel 12 will be that one, the rudder. To be clear, I can show you what it does in terms of outputs on the signals. I will just add the mixings I was discussing before. So here, for instance, let's put edit 50% here. Let's put 50% of aileron here, edit 50%. Okay, then back to the second one, I will put, for instance, 50% also of elevation. Okay, and minus 50 here, edit, minus 50 to make a mix, a delta mix. Now, if I go to this menu here, we can see the channel monitor. In the channel monitor, if I move the stick corresponding to the rudder, I can see that there is no mix on the rudder. The channel 4 is doing like that. Now, if I make some motion of the aileron stick, you see that it has impacts on the aileron, channel 1. Channel 5, forget it, but it has also impact on the channel 2. So you can see here the mixing between the both ailerons. It is exactly the same here. If I move the sticks, the elevation sticks, there is a mixer. Okay? This is very standard, like say. Now, if I go to the other channels, which are here, the other channel, remember, channel 10, 11, and 12, is a copy of the sticks. If I move the stick, aileron stick, you see that only channel 10 is moving from plus 100% to minus 100%, with a direct copy of the motion of the sticks. It is exactly the same for the elevation. Up means 100%, down means minus 100%. and there is no impact on the elevation because those channels 11, 10 and 12 for the rudder are the direct copy of the sticks. This is very important to understand that the OXS needs the direct copy of the sticks to operate. It needs both the direct copy of the sticks and the mixed channels. The mixed channels, remember, are those one, channel 1, which is a mixed, those one, channel 1 and 2 are mixed channels for the delta, and there is also a rudder which is not mixed here. Okay, now the other input that is needed by OXS is the switch. The switch, as I called it, the gyro programming channel. For me, it is channel 13. You see that channel 13 is 0 in the middle, minus 100 when it is up, plus 100 when it is down. Okay, if we play with this value of 100% or minus 100%, we can program here to the gain, the master gain of the gyros. But I will explain this later on. Now we'll have to go inside the OXS programming. We have programmed everything which is needed, or nearly everything which is needed, inside the handset. We go to the programming parameterization of the RP2040. To program the Raspberry Pi, we use the serial monitor. So when pressing return, we get the standard classical OXS configuration, where we see some channels which are already defined. Primary channel is a pin 5. We see also that I have configured the channel 1, PWM channel 1 on the pin 8 and channel 2 on the pin 4. Remember that channel 1 is the output. Should we have no mixer, it's the output of the ailerons, while channel 2 is the output of the elevation. If we have some mixings, well, channel 1 is the mixed channel 1 and channel 2 is the mixed channel 2. What else? The rest is not important. You see that we get here some gyro is not configured, which is normal. If we press the question mark to get some help, we see that we have a set of parameters which are related to gyro. We will start with this one, gyro. I will try to paint it. I don't know if it works. Yes, this one, gyro stick aileron. So we will send the command gyro stick aileron, GSA, and we will put here the channel which is reflecting the original aileron stick without mean, limit, stream, whatever. So I send this command GSA equal, remember it's channel 10. I send this. I get some errors, but it is not that important. I will send the second command, which is a stick elevator, which is channel 11. GSE equal 11. Return. I still get the IBUS errors. But we have the third gyro stick rudder GSR to program. So GSR equal 12. We will get the IBUS errors. They are connected. You see that the gyro is not configured yet because there is missing the last command, which is the switch, which is commanding the gyro. I press question mark. You see that we have one command to send, gyro mode gain, GMG. We will do it, GMG equal, remember it's the switch is on the channel 13. 13, return, we get again the IBUS errors. I have good news. We see here that the gyro configuration is now defined. We have the channels for mode gain, which is 13, the aileron stick is 10, the 11 stick is 11, and the rudder stick is 12. Do not mix those channels, aileron stick, elevation stick, and rudder sticks, with those one, the PWM channels 1 and 2, which are on pin 8 and 4. Those, I repeat, are mixed channel 1 and 2, mixed output of the TX. On top of those PWM values, the OXS will add the compensation computed by the gyro software. The other ones, 10, 11, and 12, 10, 11, and 12 are the stick copy that the pilot is actuating. Then you see also that we get some information, the gain per axis in roll, in pitch, and in yaw. We have not entered anything, so it is defined to be the maximum. The gain on throw, we will explain it in another video. The max rotate, the stick rotate, and so on. Those are fancy things that I do not master completely. The gyro mixers are calibrated, but with this, but we will now enter the calibration process. For the calibration process, we do not need the PC. We just need the handset. So I come back to the handset. I take it here. You see it, and I will let the zoom of the video like this, so that you see the screen, but more important, you see the sticks. To calibrate, and you see also maybe, if I do this, you see some information that will appear at the bottom of the screen. To perform the calibration, first of all, we can see that if I move this stick, both servos are rotating. It's normal. I get a mixer, a delta mixer on this program. We have to teach this thing, the OXS, that we have the mixer. On some gyro systems, this information is directly done with switch here, I don't know. But with OXS, we have a very clever other way to do it. It's a learning process. How do we do it? So let's do the learning process. To perform the learning process, you have to put the rudder stick to the right, the elevator up, the aileron to the right, and move 5 times this switch, which is a switch which is programming the gyro. 1, 2, 3, 5. You see that we have got here 2 lines. The learning process started and centered. And you see also that we have got here a red blinking LED, which is telling us that we have started the learning process. Now what can we do? What shall we do? I come back to this. We have to move one stick at a time to the corners. So we take, for instance, this one, the rudder, to the right. You see that rudder right has been calibrated. I do it to the left. You see that rudder left has been calibrated. The elevation down, up, and then this one, the ailerons right, left. Once we have done this, it is saying that calibration mixer is done. Switch may be changed. We change the switch, the same switch. We change the position of the switch. Like that. Click. You see that the second step of learning process is started. What shall we do during the second step? is putting the sticks 2 by 2 in the corners. We do this, we do that, this one, that one, this one plus the ailerons, this one plus the ailerons to the right, this one to the left, to the right, and this one to the left, to the right, and this one to the left, to the right. You can do this as often as you want. What is important to see is that the channel 3, which is the throttle, is locked to minus 100% because of this safety switch that I have programmed here. Or you can keep it with the stick to the bottom. I prefer the safety switch. We have finished. We have finished. You can see it with the LED, which is now again blinking blue. And if we switch this to the middle, the second step learning process is finished. And now if we do this, you can see that the gyro will be activated. So I remove this PC. I just keep my my messy servo setup. I have to untangle all this. Okay, it's done for this one and that one also, and I will put it here and here. So what happens now? If I move the stick, if I move the sticks, I will zoom a little bit. Try. If I move the sticks, you see that we have kept the mixers. So the pilot of the plane is able to pilot the plane. If I switch this one like that, you see now that I have some mixings which is done when I move, when I rotate this device. So the gyro is active. Alors this is for sure more difficult to see if we get mixings like that, because everything is mixed. It would be simpler to get a not mixed plane, but for the sake of the explanation, I needed it. So we are at that level. We are with rate mode, the switch on top. If we go to 0, you see that we get no more effect of the gyro. And if we go down, we will be in the mode hold, attitude hold, which is I follow the orientation of the gyro device. Okay? This one I have never tested in flight, but this one, rate mode, you can trust me, it is working very well in a plane. Well, I hope that everything now is less is demystified, and that you will be able, all of us, to use this very, very nice device, which is the gyro of OXS. Thank you.